Today we're going to be talking about some rules for definite integrals, and we've already talked about some of these rules. We've talked about, if A is always the smaller number, so if you have to switch basically A and B, you have to add in the negative. The integral from A to A is going to be 0, and then you can pull out a constant out in front, and same thing with a -1, that's just a special case. And then you can take a sum or a difference and separate it out into different integrals. And then if you have the area from A to B, and then from B to C, that's the total area from A to C. Okay, so we did this type of thing when we were talking about derivatives. Now we're going to be doing integrals. So what I can do is I can take 3 times the integral from -1 to 1 of h of x dx plus 2 times our integral from -1 to 1 of f of x dx. Now what is the area under the curve from -1 to 1 of h of x? Well, that's 7. So I have a 3 times by a 7 plus a 2 times now our area under our curve from -1 to 1 of f of x, which is 5. So we have here 21 plus 10, which is going to get us 31. All right, now looking at from 1 to -1. Remember, we have to add in the negative if we want to switch the location of those two integral limits. That value is 7, so our answer is -7. Our next one, from -1 to 4. Well, we know the area from -1 to 1 of f of x dx, and I can add to that the area from 1 to 4 of f of x dx. So we have 5 plus a -2, and that gets me 3. Okay, our last example. We're going from -4 to 4, so we're not going anywhere. So there is no area under our curve. That area is 0. Okay, definition of the derivative, of an integral. So when you take the derivative of an integral, and we're actually going to go into this a little bit later on, that equals f of x. Okay, it's basically the same function because remember, derivatives and integrals are essentially inverses of each other. So therefore, the integral is the antiderivative of f. So if you look at this, big F is the antiderivative. And this is something that we've defined already. We've already talked about that. So then, for some constant c, if we set our equation, if we set x equal to a, okay, this area we know is 0. So c is equal to -f of a. So this is an important definition for you guys to remember. So that when I'm trying to find the area under the curve from a to some x value, you find the antiderivative function, and you plug in the x function, and you plug in the a function. So that's what you're really doing here. So interpret the integrand as a rate of change, which is really what we did on the last slide, and evaluate the integral using the antiderivative. So first thing, let's figure out what the antiderivative of that is. The antiderivative, I add 1 to the exponent, and take 1 over that new coefficient, and I'm going to evaluate that from -1 to 2. Meaning I'm going to take, and I'm going to evaluate x to the third. I'm going to evaluate x to the third minus -1 to the third. So that's 8 minus a -1, so that's going to be 9. What's our antiderivative here? What function's derivative is sitting there? That's inverse sine. And we're evaluating that from 1/2 to 0. So I find what the inverse sine of 1/2 is minus the inverse sine of 0. So at what angle is the sine equal to 1/2? That's at pi over 6 minus, at what angle is the sine 0? That's 0. So our answer is pi over 6. Okay, find the following by hand, and then we're going to confirm it by using our calculator. So this is a little bit more of a complicated integral. What we're going to have to do is we're going to have to remember that that's x to the first times by x to the 3/2 dx. We don't have a rule when we're under a product of an integral. I can't separate those out under a product. So what I have to do is I have to change that to x to the 5/2 power dx. Okay, now add 1 to the exponent. That's going to get me x to the 7/2 reciprocal of the exponent, and I'm going to evaluate that from 1 to 4. So really what that means is I can take 2/7, I pull that out in front, and evaluate 4 to the 7/2 minus 1 to the 7/2. Okay, so remember that that bottom number, I get square root 4, which is 2. 2 to the 7th is 128 minus 1. Simplifying that all out, we get 254 over 7. Find the following by hand. I'm hungry. And confirm your answer by using your calculator. And I'll show you guys how to use your calculator by doing this here in a minute. Okay, so integral from 1 to 3. Again, there's no quotient rule, so I have to separate that out into 3x to the 4th over x plus 2x squared over x dx. So from 1 to 3 of 3x to the 3rd plus 2x dx. Now I take my integral, and we have 3/4 x to the 4th plus x squared, evaluating from 1 to 3. So what I can do, I'm going to plug in the 3 minus plugging in the 1. So I have 3/4 times by 3 to the 4th plus 3 squared minus 3/4 1 to the 4th plus 1 squared. Simplifying all that out, we get 68. And I'm not going to go through that algebra because that's just wasting time in the video. Now I'm going to show you guys how to do those last two examples by using your calculator. Okay, now doing this on our calculator. What you want to do is you want to press the math button. And you can arrow down, or you can go to the end of the list, because what we're looking for is at the end of the list. It's number 9, fint. That's function integral. And some of you, yours is going to look a little different than mine. If yours looks a little different than mine, you just have to put it in like we did with some sequence, and I'll show you guys what that looked like in class. But doing our first number, 1, 2, 4, and I'm going through the first example here of x times the square root of x to the 3rd. So that's my function. Now you need to tell it the variable. What's the variable I'm looking for? We're taking dx. So actually, if your calculator looks like this, it makes your life really easy. Now I gave us the fraction version of that, so I'm going to do math, frac, press enter, and that's what we got when we did it in the video. All right, now let's do the other one. So I go second, actually not second, just regular old math. You can just type the number 9. All right, the second one we were from 1 to 3 of our function. Now our function was 3x to the 4th plus 2x squared. That was all in the numerator. So I put that all in parentheses, divided by. And then type in what was in the denominator, which was x. Now, you have to tell it the variable dx. Press enter, and we should get 68, which we do. Okay. So that's how you do it on your calculator. Again, if your calculator looked a little different than mine, you do it just like we did with the sum sequence. You put in the function, you put in the variable, you put in the lower limit and the upper limit and press enter, and that should work for you. And I'll go through that in class in case you guys are struggling with that. So just make sure you guys remind me. Okay? So that's it for today. Please make sure your lesson summaries are submitted on time.